So last video here, we're going to be doing reactions with the hydrocarbons, so alkenes, alkynes. And then we're also going to look at reactions with alcohol and talk about a few important alcohols. So there was, I mentioned this at the beginning of the video, or the video one, but there's a lot of al questions that were originally assigned to you. I did remove some, and I, in particular, removed the reaction ones. Now, you will see reactions on the exam. My reasoning for removing those ones is because they were really difficult. They had a name plus a name, and they wanted you to do the reaction and then give you another name back. So basically, it was testing your naming on top of being able to know what the reaction did to the structure. And so I felt like it was testing a whole lot in just one question. On top of a few of them, you were given two names, but then you had to draw the product. And I know that the drawing ones in here are just kind of really difficult. So that was my reason for removing them. I know that it might seem a little backwards since these are questions you will see on the exam, but I'll put some practices on when I make a mock final exam. So again, this is a slide just reiterating what I had just said. Apparently I made a slide for it. So first, talking about reactions with alkenes, right? So these are all single bonded structures. Say something like that. So we talked about combustion reactions already. And so these are those CXHY, depending on how many carbons and hydrogens there are, plus oxygen yields water, carbon dioxide, and heat or energy. So we've already kind of seen this, but we didn't specifically talk about what that hydrocarbon was. Well, here it is. It's alkanes. So getting more into the nitty-gritty, reactions with alkenes, there's a lot of reactions that we can do. The general reaction, though, is, let's say this squiggle represents just the other parts of the structure. So we can have a double bond. We can have a compound, let's say, with AB. And what happens when we put a double bonded alkene in there with AB, we end up reducing that double bond and adding AB across it. So I'm going to draw out the implied hydrogens here. They're here as well. Oops. So that's a general reaction. So the next few slides here, I'm going to give you specific reactions. We have 1, 2, 3, 4. But if there's anything to remember, it's that anything that is added to an alkene breaks that alkene bond, and you add one component to one side and one component to the other. So looking at halogens, and so this as if AB was a halogen. So halogens are that last row in right before noble gases. So this is things like Br2, F2, iodine 2, even chlorine, right? So this is if AB were to be two halogens. So like we said, in general, we have a double bond. And if we were to add, let's just say bromide, we're going to break that double bond. and put one atom of each on each carbon. And again, I'm going to draw out the implied hydrogens. They're here. So if we got more specific, let's say we had one butene. We wanted to add chlorine across from it, chloride. We would then produce the backbone, right? We've broken this double bond and we would add a chlorine to each carbon. So we've produced 1,2-dichlorobutane. So we went from an alkene to an alkane. Let's do another example, but this time with a ring. So let's say we had cyclopentene. And let's just say for this time, we're going to use fluoride. So we're going to reduce that double bond to a single bond and then add one atom of each across where that double bond was. So now we've produced 1,2-difluoro cyclo and I'm running out of room, pentane. Okay. So let's look at the same thing here, but now this is if AB was hydrogen. So going back to our general reaction. Oops. We have a double bond. This time, what we're adding, our AB that we're adding across it is H2. This time, to do this reaction, we need a catalyst, right? So we always write the catalyst above the arrow. Don't worry about it. For this course, we don't need to memorize the catalyst, but it is technically correct to show that the catalyst that's involved. So we're going to reduce that double bond, and we're going to add a hydrogen to each carbon. And again, there was already implied hydrogen, so I'm just going to go ahead and write them all out. So a more specific example, 2-butene. All right, so we're going to break that double bond, and we're going to add a carbon, or I'm sorry, a hydrogen to each carbon. Again, there was already an implied hydrogen to each of these. And so now we're left with butane. So I drew out the implied hydrogens here, but just to note that this would also be correct. This is still butane. It's just without the implied hydrogens drawn out. All right. So we can also do this reaction where AB equals a strong acid, such as HCl, HBr, HF. So looking at this reaction in general, we have a double bond plus HX, where X equals, you know, the Cl, the Br, that yields. We add hydrogen to one atom, reduce that single bond, and add whatever else the other atom is to the other carbon. So if we were to get more specific, we're going to start with 2-butene again. It's a good example. This time, let's say we add HCl. So we're going to add hydrogen to one and chlorine to the other. So I'm not going to draw the hydrogen because once we know that we have implied hydrogen, so it doesn't really matter. And it doesn't matter for the course, for the sake of this course, it doesn't matter if you put the chlorine on this atom or this atom, carbon atom. If we were to take a more intense organic class, it would matter, but doesn't matter. It's just as long as it's crossed one of the carbons that was touching the double bond. Okay. And that's going to be my way of saying it has to be one of them that was previously the double bond. Okay. And so the name for this is 2-chlorobutane. All right. So one last reaction that we can do with alkenes is add H2O. So this is where AB is H2O. And you're like, wait, that's 3 atoms, not 2. How's that AB? So H2O will be listed like this on the product side or the reactant side. But on the product side, we're going to add an H to a carbon and an OH to a carbon on the product side. And we're going to do 2 examples here. So in general, right, we have some kind of double bond. Plus water. And this is going to yield, we reduce that double bond to a single bond, and we add hydrogen to one and OH to another. So if we're to look at a more specific example, let's look at 1-hexene. So 1, 2, 3, 4, 5, 6. It's terrible drawing. Plus water yields. We reduce that single bond. 1, 2, 3, 4, 5, 6. And then we're going to add hydrogen to one and OH to another. I'm not going to draw the hydrogen because it's already implied. And so now this becomes 2-hexanol. I could have added it to the other carbon atom. So I could have added it here. And then this was my carbon 1. 1, 2, 3, 4, 5, 6. But then it would technically take on a different name, but it is correct. So this would be 1-hexanol. Both are correct. Okay. So we did reactions with alkanes, which were combustion reactions. We just did a bunch of reactions with alkenes, which is where we add AB across it and it reduces that double bond. Reactions with alkanes, for the purpose of this course, we're not doing any reactions. They do exist, but just not for this course. So that moves us into reactions with alcohol. And so there's 2 reactions that we're going to go over. One of them is elimination, or called dehydration. So in general, we have some kind of alcohol. I'm going to draw out the implied hydrogen on this one. This happens, I don't want to say spontaneously, but there's no other reactants, but you do need a catalyst. And you do need it to be at 180 degrees Celsius. When you're under those conditions, the carbons that retained an OH and an H will then will eliminate these guys, produce water as a byproduct, and create a double bond. So kind of the opposite of what we were just learning with alkenes. So a more specific example is 2-propanol. We're under the right conditions. We have a catalyst and we're at 180 degrees Celsius. So it's going to reduce. Now, it's going to reduce this OH. It's going to take one of the implied hydrogens and make it a double bond. And so we're going to have 1 propene. It's also correct if you chose the implied hydrogen over here. The name would actually still be the same in this case. And don't forget, we're producing water as a byproduct. Okay, I'm going to erase this bottom part and show you another example, but with a ring. So let's say we had cyclohexanol. We're under the right conditions. We have our catalyst, 180 degrees Celsius. We're going to end up producing, now again, we can choose the implied hydrogen here or here, doesn't matter. And again, the name is actually the same for this one. We'll end up producing cyclohexene. All right. So one more reaction that we can do with alcohols is an ether formation. So an ether was a functional group that we had learned in the first video. It's when an oxygen is sandwiched by 2 carbons. And so for this reaction, we require 2 alcohol groups. So let's say we had something with an OH group here, another molecule with an OH group. Again, we need to be under the catalyst conditions, but we end up taking away an H and an OH, producing water, and then bonding those 2 molecules together at the oxygen. Okay, so a more specific example, I'm sorry, I should have wrote general here, is let's say we had 2 molecules of ethyl alcohol. That's the common name, but it would be 2 of propanol, 1 propanol. We're under the right conditions. We're going to end up producing water and then our ether. So this one is a little difficult. So we're gonna have what comes before it here. So 1, 2, 3. The bond to the H, and then we're gonna basically flip this in our head. We have the bond here, so this H, and then what comes after it. So 1, 2, 3. So this is diethyl ether. We don't need to know the names for ethers, but I'm just telling you. All right, so that's another reaction we can do with alcohols, is to form an ether. So lastly, I want to talk about important alcohols. I have 3 for us that we've probably heard of. We have methanol, ethanol, and isopropyl alcohol, which is also known as 2-propanol or isopropanol. So methanol is the simplest, right? It's just 1 carbon in OH group. It's the simplest alcohol, but it happens to be toxic, very toxic. So we do have this in the lab, in my lab at work, and in your guys' lab in class. I did not use it as the alcohol in the acid-base lab because it's highly toxic. There was no reason to use it if we didn't have to. So this is used sometimes as fuel for cars, fuel for like burners, like old-timey lamps. But it's just not something we want to breathe in. It's not going to kill us if we breathe it in. It's just not great for us. Ethanol, also known as ethyl alcohol, is a 2-carbon structure with an OH. This is what our like alcohol that we think of when we go out to drink. This is made of ethanol. It's a really good solvent, so a lot of things dissolve in ethanol. It's also the basis of a lot of cleaning products. And if you were to use ethanol just straight, which is what we use in the lab, it's also great at cleaning. We can add the other stuff to it, like when we buy stuff off the shelf. But if we were to just use 70% ethanol and 30% water, that's a great cleaning solution. And I imagine you might see just straight ethanol solutions at when you become a nurse, used for cleaning. So obviously this isn't as toxic to us as methanol. It does come with some toxicity, right? You get drunk, and that's not super great for your body, but it's not as toxic as methanol. So 2-propanol, isopropyl alcohol. Right, so propanol, so 1, 2, 3. This is what we consider rubbing alcohol. This is toxic. We don't want to drink it, but it's great at cleaning our body, like wounds, right? It's great at disinfecting them, but it's not something we want to drink. So here I've included another list, and they have some other uses on there. This was just from your textbook. I thought it would be interesting. Yeah. You can just look at that on your own leisure. It is interesting, I'm not gonna lie. But that is the end of the 3rd video.